This video we will be talking about the quality service of the 5G network. 5G is the fifth generation mobile networks or fifth generation wireless systems, abbreviated 5G, and the proposed next telecommunication standards beyond the current 4G standards. 5G planning aims at higher capacity than current 4G, allowing a higher density of mobile broadband users and supporting device-to-device more reliable and massive machine communications. 5G research and development also aims at lower latency than 4G equipment and lower battery consumption. For better implementation of the Internet of Things, also known as IoT, there is currently no standard for 5G deployments. 5G mobile technology has changed the means to use cell phones within a very high bandwidth. Users never experienced ever before such a high-value technology. Nowadays, mobile users have such advantage for the cell phone technology. The 5G technologies include all types of advanced features which makes 5G mobile technology most powerful and in huge demand in the near future. However, in order to meet the key performance indicators initial for KPI set for 5G networks to overcome a number of important problems researchers will need to conduct. Some of the problems will be that of supervision the expected exponential growth in multimedia traffic and meet the quality expectation of the end user. According to the latest networking forecast, mobile video will account for about 75% of all mobile data traffic by 2020, representing a 13-fold increase since 2012. Software-defined networking, also known as SDN, has been generally playing an important role in 5G network. The definition of SDN is an umbrella term encompassing several kinds of technology aimed at making the network as agile and flexible as the virtualized server and storage infrastructure of the modern data center. In SDN, the control plane is connected from the data plane. This disjointing has the capability to allow an SDN controller to catch an overview of not only the entire network containing up-to-date quality of service, information on all paths in the network, but also an overview of all competing for traffic flows at the present reversing the network. 5G network will be based on new methods of modulation and transmission that will significantly increase the spectral efficiency compared with 4G networks and ensure data transfer speed of more than 10 gig per second. To provide such data transfer speed in 5G networks, the use of broadband channels in the downlink as well as the uplink with a continuous spectrum width of 500 to 1000 MHz will be required. The amount of spectrum is 25 to 50 times wider than the channel width used in 4G. Allocation of these bands for 5G channels is possible only at the upper boundary of the centimeter and in millimeter wave bands that will significantly reduce base stations coverage up to 50 to 100 meters. The increase in spectral efficiency of 5G networks can be achieved using non-orthogonal multiple access methods, also known as NOMA, in radio access network and using non-orthogonal signals. Requirement to the cell spectral efficiency in 5G networks for divergent transmission channels are very similar to this requirement with 4G networks shows the growth of spectral efficiency by 3 to 5 times. 5G network infrastructure will be based on the use of cloud technologies, both in radio access networks, Cloud RAN, with using software-defined radio (SDR) infrastructure, and in the core network Cloud CN with using software-defined network (SDN) infrastructure. Full virtualization of NFV, also known as network functions virtualization, network functions implemented in 5G infrastructure will take place. New solutions for 5G networks will be the appearance of moving 5G nodes, they're also known as base stations, and moving 5G backhaul that is dictated by the need to implement 5G during the construction of intelligent transport network. Thanks to these solutions, international highway with cars moving at a speed exceeding 200 kilometers per hour, we introduced moving 5G communication networks constructed on the basis of M2M, also known as machine-to-machine applications, and devices for vehicle-to-vehicle V2V scenario, and ensuring the safety, traffic, and multimedia data exchange. Now we will be moving on to implementation of SDN for 5G networks. 5G networks is going to be designed to be open, more flexible, and able to evolve more easily than the traditional networks, and will not be based on the routing and switching technologies anymore. It is able to provide convergent network communication across multi-technologies networks and provide open communication systems to cooperate with satellite systems, cellular networks, cloud and data centers, home gateway, and many more open networks and devices. Additionally, 5G systems will be autonomous and sufficiently able to adapt the situation depending in required QoS to handle application-driven networks dynamically. Security, resiliency, robustness, and data integrity will be the first priority in the design of future networks. Moreover, the 5G networks will be able of handling user mobility to guarantee connectivity at any situation. The end user terminals make the final choice among different access network for the best connection. Also, the terminals will also stay awake and looking for to choose the best technology to connect with respect to the dynamic changes at the current access technology. The infrastructure of the wireless network will be based on the SDN, which provides arrange the communication between the application and services in the cloud and users mobile terminal. Therefore, the network can be managed on the real-time needs and status dynamically, and it will benefit from resource virtualization. The architecture of 5G networks based on SDN scheme has shown in this picture. Pause it if you want to look further ahead. SDN has several limitations. It has some advantages such as resource sharing and session management. The main limitation is on the computing capabilities and resource of mobile devices. As a result, because mobile users send requests over and over to embedded control for flow rules in OpenFlow messages, the overhead increases more significantly. Hence, further researches are required on leveraging SDN for 5G. Now we will be moving on to the QoS management in the 5G networks. The approach to QoS management is during the evolution of QoS management device in the 3GPP networks, there was a migration from QoS management at the end user equipment level to the QoS management at the network level. 5G networks will maintain this approach to QoS management. QoS management mechanism in 5G networks should prioritize video and VoIP traffic over web search traffic and other application tolerant to quality. Since streaming video transfer without buffering is very sensitive to network delay, thus one of the most imperative parameters that determine QoS requirements is the total packet delay budget, which is formed on the radio access networks (RAM) air interface and is treated as the maximum packet delay with a condensed level of 98%. Requirements to 5G networks will be twice more rigid for traffic in the user plane and 10 times more rigid in the subscriber traffic. Now, in conclusion, the emergence of 5G networks in the market in 2020 will be focused on improvement of characteristics of mobile networks, including quality of service. The principles of QoS control will be maintained during the transition from 4G to 5G. Thus, 5G developers should be mainly focused on the virtualization of network functions, be responsible for the management and control of QoS in the network. Thanks for watching. Please comment down any questions you have. Thank you.